This segment proof is going to look a lot like the other segment proofs. We're going to start off with what's given. Segment AB is congruent to EF and segment AC is congruent to EG. That means that their lengths are all equal, and that's by definition of congruence. Now we want to end up with a BC and an FG, so we need to introduce those somehow into the equation. I know that the length of AB plus the length of BC equals the length of AC, and now we have a BC in the proof. And I also know that EF plus FG equals EG, and now we have an FG in the proof. That is the segment addition postulate. Now we somehow want to combine both of those equations into one equation, so we have our BC and our FG in the same equation. I underline these because I want to remind myself that I'm not going to be substituting those. We want what's here and here to be the same, and here to be the same. And we can substitute because we assumed that the length of AB is equal to the length of EF. So instead of AB, we can plug in EF. I want to keep BC, and then instead of AC, the length of AC is equal to the length of EG. So we just substituted. We can combine both of these equations into one equation if one side of both equations equal each other. So this equation we have an EG, and this equation we have an EG. So both right sides equal each other. So let's set the left sides equal. EF plus BC equals EF plus FG. And that's the transitive property, or substitution. And if you want to keep your end goals underlined, that might help. BC and FG, we want to be left with those at the end. Notice there's also an EF on both sides, so let's subtract that out. That was by subtraction. Now we almost have what we need, we just need to show that they're congruent. So BC, segment BC is congruent to segment FG. That is by definition of congruence. Here's a neater flowchart of what we just did, and here is a 2-column proof.